Students, how are you? I am Tom. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we will discuss about preparation of Pyrrole. From one is Muccic acid derivative and another is Furan. Why these two are important? See, first of all, this Muccic acid method is a laboratory method for preparation of Pyrrole, and second, this Furan to Pyrrole preparation, this is industrial method. So this is the actual structure of Pyrrole. Why I have written? Because always keep this thing in mind and try to think. And what reagent I am taking, you also try to think how I am going to do mechanism, how I am going to do. So just don't only listen. Try to think by yourself. And if these two, first of all you are thinking, second you are watching, then your understanding level will improve. And it will be easier for you to remember for a long time. Okay, let's start. So, actually Muccic acid has another name. That name is galactoric acid. Actually better to say D-galactoric acid. Means carbohydrate is a 6 carbon, both end OH. 1, 2, 3, 4. Fine. COOH. So this is the galactoric acid. So okay, I should not say about the geometry. So hydroxyl, 4 hydroxyls are there. Okay. So don't be confused. Actually, I also forgot. So this is the thing of galactoric acid. So this galactoric acid is used for the preparation of Pyrrole. So how this is happening? Let's explain. So you can use directly galactoric acid. So if you use acid, then we need an ammonia source to convert these into corresponding ammonium salt. Okay, so this is minus, this is plus. So this is, and how we can get, we have to, in presence of this, actually liquor ammonia is needed, evaporate to dryness the reaction mixture to obtain the final salt. Okay, and if you are taking directly this ammonium galactorate, that's fine. Secondly, if you actually I want to prepare Pyrrole, then it's ammonium, fine. If you want to prepare substituted Pyrrole, for example, R substituted, then what we need to take? R NH3. Please keep this thing in mind. Okay, fine. So this is a salt. So what happens? Actually, see, ammonia is not that much a strong base. So this can provide RNH2 plus H plus. So you may think that there are some H plus in the reaction medium. So what happens? And previously I have discussed about the 1,4-dicarbonyl compound. So it will result in 1,4-dicarbonyl. It will result in 1,4-dicarbonyl. I suggest you pause the video and try by yourself to prepare this 1,4-dicarbonyl compound from this. It is a very good thing. I believe you will have a better experience or understanding. Okay, I hope you have tried, so let's start. Fine. So, 1,4-dicarbonyl means this. This, okay. So, 4 carbon, fine. So, let's put CO2H, CO2H. Fine. Since we have taken ammonium salt, so, okay, I am not focusing that thing, but just think CO2. Now, see, 1,4-dicarbonyl. So, dicarbonyl I have written. Okay. So, and another thing, previously all was single bond. Right now there is double bond. So, it means some elimination occurred. So, who have eliminated? This OH, these two has eliminated. So, what happens? Just think. So if it eliminated, there are lots of H plus. So first of all, this is OH. I have written because it will give you a better understanding about the process. Fine. So this is OH, OH, OH. So it undergo protonation to form OH2 plus because see there are proton source. So fine. Now it will leave. Okay, it will leave, then what is expected? So a carbocation type will form. Generally, it is expected that a carbocation derivative will form here. Okay. So, if it is, then means actually here H, so OH eliminated. So from nearby carbon, this proton will be eliminated. Who can do this job? Ammonia molecule is there. So this nitrogen can do this elimination. So what will result? A double bond. OH, OH, double bond, CO2H, here OH, here CO2H. Fine. See, this is actually a enol, so instantly it will rearrange to the corresponding keto isomer. So CO2H, OH, keto, CO2H, here OH. Similarly, another step happened having a similar process, and what it will result? It will result the second keto. This. Now you may confuse that why I have eliminated this, not this. Am I doing any partiality? No, I do not have any preference. It's molecular property. Okay. So why? So if you think this is eliminated, so what is the output? This is CO2H. Let's focus on the one part. This. So plus charge is here expected generated. Then proton will be abstracted. Okay. So see. First of all, positive charge is relatively less stable because adjacent group is carboxyl. Okay. Second, its acidity is relatively less. How? See, here positive charge is relatively more stable because carboxyl is far end. Second thing, see the proton is an alpha of carboxyl group, so relatively acidic because of the polarity or withdrawing effect of carboxyl group. So this position, both way it is favored. So that's why it is logical. I am not saying that this has happened, I do not have any proof, but it is my logical explanation. Because of this is following this path. Okay, fine. So till now we have achieved these 1,4 dicarbonyl compounds. So now our target is to prepare furan. Pyrrole. So how this pyrrole is prepared? First of all, this is prepared by reaction of ammonia or amine via sheet-based condensation. Okay, sheet-based condensation. What happens? If you take RNH2, I am not going to explain because in the Pyrrole method I have described in detail. So just I am showing. So as a trick you can see there is a NH2 means amine and there is carbon loop. So when they undergo sheet-based condensation, condensation word means water is eliminated. So what happens? You may follow a trick. Trick means you can take this oxygen and the 2 nitrogen and eliminate them as water. And what they will result? So this and this will form double. So carbon double bond N will prepare this CO2H. Fine. So then you don't think that another will do this. Logically possible, they can do, but compared to that, this nitrogen is sufficiently enough nucleophilic that it can attack. And see, this is actually a dicarbonyl because carboxyl group, this is carboxyl, 1,2 dicarbonyl group is present. So this carbon is significantly enough electron deficient such that this nitrogen can attack using its lone pair. So it will open. So what is the consequence? It will result a 1, 2, 3, 4, 5 member ring formation. So what is the consequence? So this is the 5 member ring formation with a plus charge. See, this is a OH, this is COOH. So next step, see this is a aminal type derivative. So actually see, there is nitrogen became positive charge, and that is the reason why this proton will be abstracted by other ammonia molecules. So if it abstracted, then it will go, it will come. So what is the consequence? Consequence is shifting of double bond and charge neutralization. This right now nitrogen has lone pair, and there are small amount of acid molecules of which may protonate this, or see there are carboxylic acid also, fine. So like aminol, it undergo, like you may think that hemiacetal type of thing under acidic medium. Okay, so it will leave. So what is the product? So it will result this CO2H, this CO2H, fine. This is having a plus charge, and there are still 2 hydrogens. So in next stage, what is expected? See, this molecule is losing the stabilization due to conjugation because of this, and there are lots of ammonia molecules in the medium, so it will be abstracted. It will come and it will go. But here no reversible sign. This is a completely irreversible, because in the final product aromaticity is gained. This aromaticity is gained, and that is the driving force. So aromaticity is the driving force, and you know that aromaticity is a very good stabilization energy. I have explained this in the Huckel's theory video. Please go through that if you want to learn it. So fine. So in this way, using mucic acid, this is Pyrrole is used. So instead of RNH2, if you use ammonia, then there is hydrogen. Okay, sorry, I have not Pyrrole. So under heating, what happens? These 2 carboxyl group eliminates and resulted in, this is the Pyrrole, along with that 2 carbon dioxide and 1 ammonia molecule. Fine. So this is the overall ammonia or RNH2, whatever you think. So this is the overall mechanism. Okay. So fine. So we have discussed the laboratory method for preparation of Pyrrole from mucic acid, or better to say ammonium or alkyl ammonium mucate. So now we will discuss the second part of this lecture, that is preparation of Furan, preparation of Pyrrole from Furan. By the way, when I am saying preparation of Pyrrole from Furan, there a simple question comes: how Furan is prepared? Actually, I have explained this thing in the previous video, but still I am telling here. There I have explained in details, so please go visit there if you want details. But shortly, from aldopentose, it's a C5 sugar. In presence of acid, it undergo condensation reaction and resulted in preparation of Furan. Okay, actually it results in this 5-member thing results in furfural. Okay, and that undergo decarbonylation, means carbon monoxide removal, to prepare Furan. So from this Furan it is produced. So let's describe the mechanism. So this is the Furan in presence of alumina. Actually alumina is a Lewis acid. Okay, it's a very good Lewis acid. So it results with ammonia to prepare Pyrrole. So one information I want to mention: when you have such transformation, you should use your common sense. If you don't know the mechanism also, you should use your common sense. What? See, what is breaking and what is making? Actually, these bonds are breaking and this is making. So our mechanism should involve this bond. We will not go to other bonds. We will not disturb. Okay? So that is the background information for you to understand. And ammonia is more nucleophilic than oxygen. Okay? So what happens? Ammonia attacks here. It opens. Now question: why? The exact reason I don't know, but I believe there is some interaction with this Furan oxygen with the Lewis acid centers of alumina. Okay, that is the reason it activates. So fine, it reacts. So what it does, this charge is opened. This is actually furan is an allyl ether. See the double bond ether. So this is NH2H. Fine. So what happens? Nitrogen having a positive charge. So in the second step, what is expected? It can come back and it can leave. Simplest way. And by the way, I want to mention the aromatic stabilization energy of furan is lesser than pyrrole. So that is another thing why how ammonia can go and attack, but the reverse reaction does not form. Okay, that's why we ultimately end up with this pyrrole molecule. Fine. So it opens. So in such cases, I always suggest you, first of all, it will remove one proton to become neutral, and second this. So this is double bond. This is double bond. This is, and one proton was eliminated from here, which will be abstracted by this. Okay. See, this is actually a enol. You may say that, sir, this is also aminal. Yes, possible. So we may think it in this way that it will undergo tautomerization, and we know that ketose, energetically it is more favorable. So, okay, first of all, it is better to see those. Fine. Now the question is, what happens? See, this is a delta negative, this is a delta positive electrophilic center, so nitrogen has a lone pair, it attacks and it opens. So what is the product? It produces NH, double bond having a plus charge, and here O minus. See, nitrogen having plus charge is it want to leave. Yes, nitrogen having a plus charge, it want to leave proton, and it has a minus charge, it want to take proton. So consequently, what happened? They will exchange proton and ultimately result in this. Now you can see this is still now this is fine. Still, nitrogen has the lone pair, but I suggest you never do the mistake that okay, this and this. No. Because then nitrogen will have two double bond having this bent structure, logically not possible. Okay, so don't do this. Before that, we need to think about the corresponding. This is imine. It's corresponding the double bond derivative. This. Okay, so right now it has a hydrogen because of this tautomerization. So right now it can push because in medium this is, and see there are other molecules which have done in this phase, so they want to release proton, so that proton could be abstracted by this and it could be removed. So what is the final product here we are getting? We are getting this is N having plus charge, this is this. Now see, because of this proton these cannot achieve aromaticity. So another molecule, for example, some another stage of this molecule like this O minus or this OH can abstract this proton, and if it is, it will come here, it will go here. So what is the product? This is our target product pyrrole. Why this step is so much facile? Because aromaticity is gained here. Is the driving force. Okay. So this is the overall mechanistic description of this industrial process for preparation of pyrrole from furan. Okay, so this is the end of this discussion. Thank you everyone for listening. So today we have discussed about the preparation of preparation of pyrrole from, one is mucic acid, or better to say ammonium or alkyl ammonium mucet, and second is furan using this. So first one, this mucic acid method is the laboratory method for preparation of furan, laboratory method for preparation of pyrrole, and this furan to pyrrole, this is the industrial method for the preparation of pyrrole. Okay, so this is the end of this discussion. I hope you have enjoyed this video. Please write your feedback on the comment box. I shall try to improve myself accordingly. And if these videos are useful, please help my channel to grow. First of all, Please subscribe my channel Chemistry the Mystery of Molecule and press the bell icon to get the notification of every single video I upload. And secondly, please share this video among your friends so that many people could be benefited from my effort. And thirdly, please like this video and make some good comments on this comment box. It will be very good achievement from me. Blah blah blah. You know it's everything I am telling every day. So thank you everyone for listening. See you in my next video.